All right, these are guided notes 1.7, and this is set 1F. All right, so lesson 1.7, we're going to use some existing data from another class to record. It says find the total number of colleges your whole group is applying to. So me asking you how many different colleges do you think you're going to apply for? So we're just going to go with a random preset set of data right here, and then we'll talk through the values here, okay? Okay, so this says 1.7 notes are about measuring center and variability. Standard deviation is a measure of spread or variability. Okay, so standard deviation, or SD, the smaller the standard deviation, the less variability. So to visualize that, you see this curve here. If the values are tight together, close together, then this has less variability, versus something that has a larger standard deviation, that means it has more variability. So something like this, right? Another way to see it is with dot plots. So an example of a set of dot plots that has a small standard deviation is if maybe they are kind of like this. You see here that they're like more clustered together, versus something like this where the values are far away from each other. So notice that there's like three here. They're away from each other. So something like this would be a large standard deviation, and something like this would be a smaller standard deviation. Okay, so for the example, it says find the total number of colleges your whole group is applying to. Record the data for the class here. So this is an example. Say we survey 8 students, and say one student says 5 colleges, another student says 4 colleges, and so on. And the last student says 3 colleges. So here is the set of data. Question number 2, it says calculate the mean and the median. So the mean we use to calculate the mean, or X bar. We add up all the numbers and divide by however many numbers there are, so 8. And to calculate the mean, you don't need to put them in order, but to calculate the median, you need to rewrite these in order, from in increasing order. So just put them in order: 3, then we go to 4. I see a 5 and a 5, 6. Oh, there's another 3 there. So there was a 3 and a 3. There was a 5 and a 5, a 6 and a 6, and the biggest number is an 8. So now that they're in order, you could figure out which number by taking one away from here, one from here. See what number lands in the middle. So here we have 2 that are in the middle, but if you find the average of this, the median is still going to be 5. So compare the mean and the median have the same. For this example, they have the same amount. All right, number 3, find the range. Oh, let's see. Whoa. Okay, I'll leave it like that. Finding the range is helpful, but it doesn't tell us how spread out the data is between the min and the max. The standard deviation lets us find the average distance of the values from the mean. So the average distance from the mean. And what we do in this table here, in each of the boxes, put each of the numbers that we collected. Okay, so put each of the numbers, put them in here. And then the second column, it says distance from the mean. So this whole table, this is the long way, or how to calculate the standard deviation by hand. Okay, so all this work for the table is how to calculate the standard deviation by hand. So you see here that you put all the numbers going down. Distance from the mean. So that means that you're gonna take each x with a subscript of I, means you take each individual value from the list and you ask yourself, how far is it from the mean? So the mean that we want to use here is 5. The mean was 5. How far is 5 away from 5? 0 units away. How far is 4 away from 5? It is 1 unit away, but if you subtract it, you get -1. That just means it's, it's still 1 unit away. So you repeat that process. You subtract each of these numbers by 5, and you get these numbers. To get the third column, what you're going to do is you're going to take what you saw here and square everything, and so on and so on. And that's the work here. That's how we get 0, 1, 1, 0, 4, 1, and 9. So it doesn't matter that we got negative values here. When you end up squaring it, you get a positive value. Okay. So moving on. So we take to figure out this box here. What you do is you're going to take all these numbers here and you're going to add them. You're going to take the sum, add them all together, and you get 20. Okay. And then this column or this box here that says the average distance from the mean. So if you want to find the average of these numbers, you add them all up and you divide by however many numbers there are. So there was actually 8 numbers. Remember we said there was 8 numbers. So you divide it and you get 2.5. This 2.5 is not the standard deviation. So we look at question number 4. How do we use this? The average you calculate is the average of the squared distances from the mean. How do we use this to find the distance from the mean? We're going to take the square root. So you're going to take the square root of this, and notice that is going to be 1.58. All right. Question number 5. It says to use your calculator to get the summary statistics or the one variable statistics. Here's the commands, but for our purposes, we use give me a second here. So to go over the calculator commands, here are the calculator commands. So the way to do it, from your home screen on the calculator, you'll click on number 4, add a list or spreadsheet. You're gonna get a screen like this. You gotta put a name on that column. So for example, you'll put colleges here, and then in each cell type in each individual value. So you put your eight values down the row. Don't put anything in this where it says equal. So you skip a row and put the data in a column. Step 3, you'll go to documents, insert, calculator, and that'll take you to a new page. And then follow menu for step number 4. Put menu, statistics, and one variable statistics. You'll get a screen like this. Click OK. Step number 5, choose the name of your list. So right here, there's a little drop down menu where it says X1 list. Go to the drop down and pick the name of the list. So for example, colleges. Click OK, and then you're going to see the one variable statistics pop up in a screen like number 6. And that one variable statistics is going to show you everything you need to know for whether it's the mean, standard deviation, S of X, or sigma of X. Both of these are standard deviation. One of them is for population and one of them is for a sample. And back to our document here. So once you run the one variable statistics, look for the variable that looks like S of X. So S of X is going to be 1.69. If you compare it to our square root, when you take the square root of this, if you compare it to our 1.58, you're going to see that here in the green it says this is larger than our value of 1.58. So if you want to get closer to the 1.58, so we decided so we divide by n minus 1 instead to be more accurate. Okay, so instead of dividing by 8, you'll take your 20 divided by 7, and then you'll take the square root of whatever you get in here, and that should give you 1.69. Okay, so make sure we use n minus 1. Part Question 6. We forgot to add Ms. Ledesma. She applied to 20 colleges. So we're choosing a really high number right here, say 20 colleges, or is going to be considered like a high outlier. So now that we did this work for just 8 values, what if we introduce a new value, say 20, to the data set? How does this change things? So we add the 20 to the data set, we calculate the new mean, the new mean, median, and the standard deviation. How does it compare and why? So what you're going to see there is that the new mean, instead of 5, now it is, so the X bar, now it'll be 6.67, and the median will remain at 5, and the standard deviation, S, capital S with a little subscript of X, it'll be 5.244. So a big takeaway for this lesson is this box right here. This is what you want to take away from this lesson. So introducing a new value like 20, the new mean and the standard deviation are larger since the larger outlier increased the total, which affected both. The median is not affected by the outliers. This is a big idea for this lesson. The Continuing with the notes here. So the formula for the standard deviation formula we say is SD is equal to the square root of the summation of each x with a subscript of I. That means each individual value gets subtracted by the mean, and then it gets squared and divided by n minus 1. And your very last step should be square rooting at the end. The very last step should be the square root. This formula, you went through it in the table, so you could see that it's a lot of work doing it by hand, but the calculator and the formula is there to make things better. And remember that we use one variable statistics. Okay, and when we're talking about measures of center, we use the mean, median, mode, quartile 1 or quartile 3. Statistics that we use for measures of spread, we could talk about the range, IQR, the variance, and now you know that is the standard deviation. And now to talk about shifting data, consider this example here. You have a list 5, 5, 10, 35, and 45, and it's telling you to add 5 to each value. So to each of these numbers, add 5 to it, and we're going to compare what happens when we add a value to each of the numbers. Okay, so from here to here, add 5. So this will be 10, 10, 15, 40, and 50. Okay, and we're gonna find the mean and the median. So we'll find the mean and median for each of the sets. If we add up all these numbers and divide by however many numbers there are, 1, 2, 3, 4, 5, if we divide by 5, you'll get a mean of 20 here. And the middle value is going to be 10. Same thing over here. If we find the mean of this set, the mean will be 25, and the median, it'll be 15. Okay, and look at what's happening here. The mean, the old set had 20, the new set has 25. So by adding a 5 to all the values, it increased this. The mean went up by 5 and the median went up by 5. The spread. Let's talk about the range. Let me use a different color. Let's talk about the range and the IQR. And if you have your calculator, actually, let me make this. Range, IQR, and the standard deviation. Okay, so looking at these values, the range is 40, the IQR will be 30, and the standard deviation is 18.708. 18.708. On this new set, if we calculate the same variables here for comparing purposes, the range is 40. 50 minus 10 is 40. The IQR would be the third quartile minus the first quartile. You'll get 30. And the standard deviation is 18.708. All right. So notice that from here to here, everything is the same. Everything is the same. So for our guided notes, we see that adding a constant to all of the values in a set of data adds the same constant to the measure of center. Adding does not change the spread. Okay, so this is very important. And here you can see if you want to visualize shifting data, here's the original set. Here's the set when you add a 5 to everything. And here you can see that you still have the same amount of dots with the same pattern, but you just see that the pattern was just shifted to the right, kind of shifted to the right, 5 units to the right. But it kept the same shape, it kept the same spread. The only thing that changed was the mean and the median. It went up by 5. Let's do one last one where we consider what happens if you multiply. What happens if you multiply? Okay, so now here we have 5, 5, 10, 35, and 45. Multiply each value by 2. So we multiply everything by 2. This gives us 5 times 2 is 10, 10, 20, 70, and 90. The measures of center. So for the mean, it'll be 20. The median will be 10. Here's the median. Over here, the median is 20. Oh, the mean, if you add all these up and divide it by 5, you're going to get 40. The median is 20. Here's the median. So compare them. What happened with this to this? So by multiplying 2 to everything, we are rescaling the data. So now we see that the mean went from 20 to 40. The median went from 10 to 20. So it got multiplied by 2. The spread, so the range, IQR, and the standard deviation. The range is 40, 45 minus 5. Then it's 30 for the IQR. And the standard deviation is the same thing, 18.708. You could get this value by the calculator. And the new spread, by multiplying everything by 2, the new range is 80. 90 minus 10 is 80. IQR is 60. And the standard deviation is 37.0. 416. So this is called rescaling the data. Look at what happens from here to here. Everything got multiplied by 2. So there was a change. So we say we rescale. We're going to rescale the graph by multiplying the same number to each value. Okay, so here you visualize it. Look at how these look like. These look like they're very tight together. And then if you multiply by 2, you rescale the data, and it looks larger now. It looks more spread out. So by multiplying a constant to all the values in a set of data multiplies the same constant to the measures of center and spread. Here you see what happens. The 40, the 20, and the range went to 80, 60, and 37.416.